Jim Adams is a horticulture manager at the United States Botanic Garden. He manages all horticulture operations at the garden, overseeing the care of our vast living collections, which include over 65,000 individual plants. Jim is fascinated with plants and enjoys growing a wide variety to create beautiful and educational spaces. We're excited to have him here today talking with us about our corpse flower. So take it away, Jim.
Thank you so much, Libby. I appreciate that. Yeah, I'm really excited to be here today because we're talking about the corpse flower. And actually, I remember as a kid reading about this flower and thinking, wow, that's so cool. It'd be so cool to see one of those someday. And actually, being a resident of Washington, D.C., and the U.S. Botanic Garden being my neighborhood garden, I've actually been to see every corpse flower that they've had in bloom. And 3 years ago, I was able to join the team here at the Botanic Garden and be able to experience the corpse flower firsthand and actually get to work with the gardeners who grow these amazing plants and hear from them and learn from them what they do and how they do it and how they get these things to grow, and also to be charged by their enthusiasm. So it's really an honor to be here and to be sharing all this with you and being able to teach a little bit about it. So why are we, well, first of all, I'm going to talk to you about a little bit about the conservation programs that the U.S. Botanic Garden is involved with. But I want to just tell you, you're probably like, well, obviously you must be excited about this flower because you're here in our program today. But look at this thing. Look at this beautiful, magnificent thing behind us. That is almost, it's actually, as of this morning, it was just over 8 feet tall. It was 8 feet and then 1/2 inch. It's been growing, I don't know, anywhere from 4 to 7 inches a day for the past 2 weeks. And I think it's going to flower. This morning I thought it was going to flower this evening, but now after consulting with some of the gardeners, probably tomorrow evening. So this is the world's largest unbranched flower. And you might say, well, what does that mean? I thought it was just the world's largest flower. Well, there's different types of flowers, and this is an unbranched flower, which means there's lots and lots of little flowers in it, but it resembles one big flower. And many of you could relate to a sunflower. So it's very similar to a sunflower that has lots and lots and lots of little flowers, the disc flowers in the middle and the ray flowers on the outside. So it looks like one big flower, but it's actually made up of a whole bunch of little flowers. And that's what this is as well. So within, so you can see all the crinkled leaves or the crinkled spathe around the spadix. And it's at the bottom of there that all the male and female flowers, hundreds of them, are crammed together. As you can see in this picture here, these are female flowers at the very bottom. So those are when the flower opens, that's what's receptive first, followed by a day later, the male flowers, and where the pollen is made. So you can see see the pollen in that picture there. So what's going to happen when this thing opens up, probably tomorrow night or the night afterward, it's going to get really hot and really stinky, and it's going to attract beetles and flies that are used to feeding on carrion, feeding on dead things. As things grow and die and rot, that's all part of the chain of life where the insects come in and help to degrade it and take it back to compost. So that's why it smells so bad, and that's why it gets hot, so that it actually almost seems like a dead body to those insects. So it's a really cool thing, isn't it? Like it's huge, and it's just so interesting in so many aspects.
Jim, how many do we have in our collection approximately?
I can tell you, right? We have 50 accessions. So we have 50 different individual plants in our collection and 57 plants total. So we have a lot of them. And actually the majority of them came from the blooms that we had 3 blooms in 2017, and we were able to collect the pollen from the first one and then pollinate the second 2. And so it's from those seedlings that we have so many. So we have 57 in the collection right now. Yep, Jim, another question?
We did have a question. How can it grow 20 feet and still be considered one leaf. So I guess they're asking about it when it's in leaf form and not when it's in sort of its inflorescence mode.
Yeah. So a little bit more about the plant. So we just talked about how cool the flower was, but actually the leaf itself is really cool, because once this is done and it either sets seed and it holds on those seeds, so when this flower collapses, and hopefully we are gonna pollinate it, and I'll talk a little bit about that later. So then it'll sit dormant for a while, and then it'll send up one leaf. And actually, the stem of the plant is the corm that you see in this life cycle right here. So the corm really is the stem, and the stem is all beneath the ground and condensed into that one corm, and then it will send up one leaf. And the long stalk that you see is actually the petiole. So for those of you that live well, in a temperate climate, and you think of a maple leaf or an oak leaf, that little attachment from the leaf blade to the stem, to the branch, that's a petiole. And the big stalk that you see here is actually the petiole. It actually is part of the leaf. It is not a stem. And then the leaflets are the big whorl on top. And those can grow close to 20 feet tall, and they're quite impressive, and they actually look like a small tree in and of itself when it's not in flower. And that leaf will last anywhere from a year to maybe 14 or 16 months before it actually will die, wither, and die down, and it'll send those carbohydrates back into the corm, and it will do that for as long as it wants. There's really no rhyme or reason for as long as it does it, until it has enough carbohydrates and the plant is ready to flower again. So yeah, so that's a little bit more about the life cycle. So it's a really fascinating plant. It's an interesting plant, and it's also has a very small natural range, and that natural range is in Indonesia, Sumatra, Western Sumatra actually, and where it has been growing happily and in hot, humid environment. And when we grow it here, we try to replicate that environment. So we keep it between 70 degrees at the coolest, 85 degrees warmest, and anywhere from 60 to 85% humidity. So nice and hot and nice and humid. The leaf actually starts to crisp up and wither if it gets too dry. So it really wants to be humid and hot. And that's what our gardeners do. They replicate that environment of Indonesia. And however, right now it is an endangered plant. It is listed as an endangered plant by the IUCN, the International Union for the Conservation of Nature, and which means, and actually there's less than 1,000 individuals, excuse me, left in the wild. And unfortunately, its habitat is being degraded by deforestation, by logging, and also agriculture, by oil palm plantations. So the future of it in the wild is not very promising. So actually, as part of our mission for conservation, we have been working with Botanic Garden Conservation International and some folks at the Chicago Botanic Garden. And in 2018, we co-hosted, or we funded a worldwide conservation conference on aroids in general. So this plant is in the aroid family. So the same family as a calla lily or a philodendron. And or for those of you from temperate climates, you may be familiar with the jack in the pulpit in your local forests. And so that's the aroid family, and this is in the same family. And so the conference that we funded in 2018 actually brought folks together from botanic gardens around the world to talk about the conservation of the family. And from that came a project that the folks at some of the scientists at Chicago Botanic Garden are working on, that they're trying to replicate zoo models. So right now, like the international community of zoos keeps the pedigree of their animals and keeps something similar, keeps like a stud book similar to what racing horse breeders would keep. And this actually takes in the pedigree of all of for zoos, the animals, and this way they're able to crossbreed them to make sure that they're maintaining genetic diversity. And so the folks at Chicago Botanic Garden decided to replicate this model in the Botanic Garden world, so that, and what they've done is they've started to collect the DNA from several institutions on Amorphophallus, and we are one of the institutions that have donated every single leaf tissue from every single plant in our collection, so the DNA could be extracted and recorded so that they can begin this process. So this is really just starting right now. They are doing it for some other species as well, like Brighamia, which is a plant native to the Hawaiian Islands, actually the island of Kauai, which is extinct in the wild, but very, very prolific in botanic gardens and actually the nursery trade. But in order to make sure that we're maintaining genetic diversity so that perhaps one day it can be reintroduced to the wild, or that it actually is resilient to disease and insects, that we're trying to make sure that cross-pollination is happening to make sure that diversity is continuing.
So Jim, would you
Yep.
would you say that is the species survival plan? Like, is there an official survival plan in place for the corpse flower?
Yeah, that is the closest that right now. So that is something, because this is endangered and such a fascinating plant. Yes, then this is the best survival plan for it, and that's what we're trying to get ahead. That's what the Botanic Garden world is trying to get ahead of before it's totally gone in the wild. That we can actually see the entire genetic diversity of this plant worldwide. Actually, in the Botanic Garden world, I know for a while there was really, for I would say now maybe the past 25, 30 years at the most, there's been lots of gardens who have been growing this, and actually private collectors as well, but they've come from so few sources. So this is a way to see who's growing what, where the diversity is, what the specific DNA is, what the genes are, so that we can work with each other and see who has what and where the pollen is kept in the freezer and then shared with other gardens. So actually, the plant that we're looking at here that's in flower, this is one of 3 seedlings that we got. We got 3 seeds from a private collector in 2008. And it was a private collector who was really interested in this species, and actually in Amorphophallus in general, and several other species, but was interested in continuing the genetic diversity. I think he realized at that point that most of the plants that were in the hands of botanic gardens and collectors were just from a few small sources. And so he was interested in collecting the pollen from different gardens and crossing it with other plants, and then and recording that provenance. And actually in 2008 or 2007, saw that we had these plants here at the US Botanic Garden, and we not only grew them, but we shared them with the public. We were really excited about them, and we share them with the public. We like to teach people about them. We like to teach people how fascinating they are and how they're related to other plants in that family, and how important they are to the ecosystem from which they came. So he contacted our curator at the time and said that he had these seeds from these plants. The one parent was from Binghamton University in New York, and the mother plant was from Wisconsin, from Milwaukee, the Milwaukee Public Museum, and asked us if we wanted them. They were probably genetically different than the ones we had, and our curator was super excited to get them, so he sent us 3 seeds, and we had 3 plants from there. And actually, the one that you're seeing now, this is the first time it's blooming. We grew it from seed, planted January 9th or 19th, I'm sorry, I don't remember, in 2012 or 2008, and so we've had it for 12 years, and this is the first time it's flowered. And I don't know if you can see the small one. Can you see the small one over there, Libby? So the small one, we have another little one coming up into bloom over there. And actually, this is one that we had bloom in 2017, and this is a propagant. So this is so Libby's showing you a picture of that. And actually, if you look down at the bottom, you can see a little window cut in there where we pollinated it. So this one, actually, after it flowered, made some offshoots, and there's our curator at the time pollinating it. Actually, the corm split, so it actually made some propagants off of it. So this is a propagant from it that was then divided and potted up a couple of years ago. So this plant really blooms quickly, which is awesome. If these are ever like available at your local garden center or houseplant store, I think it'll probably be the genetics of this guy, because it blooms so quickly from either a seed or propagant. So we got it in 2008, and in 17. I mean, from a seedling, it had that beautiful dark colored flower that Libby just showed you.
Jim, do you know how many years has the USBG been growing Amorphophallus titanum? Do you know offhand?
Yeah, I know. I know definitely back in the like late 90s, there was a plant that I remember when on a visit that I had to the production facility. So yeah, maybe it's 25 years or more, maybe 25 to 30 years we've been growing it, but not really successful blooming it until the early 2000s.
Yep. Oh yeah, Devin. Thank you, Devin. Just posted in the chat something about how we've been growing it about 20 years. First bloom in 2003. So right on target. Awesome.
Yep.
We did have another question that was a little bit more related to the actual plant itself, and that was, what is a petiole? How do you know if it's a petiole, not a stem? I would also add on to that, how do you know if it's going to be a bloom or just a leaf?
That's a good question. So knowing your plant morphology, that's how you can tell. So if you tune into Susan Pell on Monday when she talks about morphology, you'll get a good taste of that. But knowing the plant for us, because we know that it is a corm, and a corm really is a modified stem, and all of the stem tissue is in that corm. Yep, right there, that's a very good picture that Libby's showing you. So actually, this is the corm of the one that's in flower right now behind me. And so that is all stem tissue down there. It's solid stem tissue, and it is just one leaf attached to that. So in the center there, yep, you can see an old stem, an old petiole there that has withered up and fallen away, and then the gardener has kept it clean as it withered away, so that we could keep it nice and dry and clean, so it doesn't get any infections, or any pathogens are introduced. So yeah, so you really need to know the morphology of the plant, know what it is, and pretty much any plant. Is it a hardy woody plant? Is it a herbaceous hardy plant? Is it a bulb? Is it a corm? So really knowing your plant and knowing that, and being able to look at it and see how the leaf is then attached to the stem. So is there knowing those attachments? So and that's what's fun about plants, because they are different, and there's so much mimicry that gives you something to look up and learn. So what was the other question, Libby?
I think you pretty much answered them. It was just, how do you know if it's going to be a bloom or a
how it's going to be a bloom
or a leaf?
So that's a great question. So they sit dormant for long periods of time, and then just as they start to grow, they look the same. It's these bracts that are folded over something, and what that is, we don't know right away. And we start to guess when they get to be, I don't know, maybe 8, 10, 12 inches high. We start to make guesses, and there's lots of poking and prodding. And as you can see in the life cycle here, they look very much the same when they come out. But then when they get to be about, I don't know, a foot, maybe 16 inches, if you start to squeeze the top, because the leaf is it's so top heavy with leaflets, that most of the mass, when you start to squeeze the bract, it'll be in the top. And so those are all the leaflets that are forming that are going to eventually get shot up by that petiole and make that big canopy of leaflet. And as it starts to grow, if that doesn't feel quite as dense, and it's kind of airy and gives, and the bottom is more dense, as you can see on the plant behind me, it's kind of swollen at the base. And when those bracts start to feel empty at the top and fat at the base, then it's probably going to be a flower. And then as it starts to grow a little bit more, if that bract starts to flare out, then it'll probably be a leaf, because that needs to support that petiole and that big 16 to 20 foot tall leaf. But if it starts to shrink, so if it comes up and it's swollen and then shrinks, it's more likely going to be a flower, because the pedicel that supports it is smaller than the base of the flower. So the pedicel supports the flower and the petiole supports the leaf.
Awesome. Thanks.
But I've also known many gardeners. I'm sorry, Libby. I know many gardeners who have. We've made a guess and we said, nope, this is definitely going to be a leaf, definitely going to be a flower. And 3 or 4 days later, nope, we were totally wrong. So yeah, so that's always a fun debate.
And then once we know it's going to be a bloom, we have to hustle to get it up so the public can see it, right? Like it's a little bit of a speedy race.
Right. That's right, up till now. And we do that, and we do it as soon as we know, because they become very fragile. And we have to load them onto a truck, strap them down. They have to hit every pothole on 295 until they get here. And then they have to be lowered down, put on a dolly, and moved in here. So we want to do it as soon as possible while the center of gravity is really low and lesser chance of breaking. However, this year we have planted 2 of these. We have 2 individuals planted in our tropics. So the gardener and I have decided, let's get them in there. Actually, the gardeners, with my consultation, and yes, let's get them in there. Let's get them growing, so that maybe someday we can just have them growing and looking the way they would grow in their natural habitat. So yeah, someday you may just see one inside the tropics.
Awesome. Yeah, we did have a question about where they're actually grown and if the public can see them. So I mean, right now the public we aren't open to the public, but in normal times, yeah.
Yep. So currently 55 of them, or actually 53 of them, are at our production facility in Southwest Washington. And then in normal years, we usually have an open house in March. So watch our programming, and when we get back to normal someday and have that open up, you can come to our production facility and see where the majority of them are grown. So 53 there, 54, 55 are right here, and 2 are in our tropics, permanently planted in our tropics.
And the ones that are permanently planted in the tropics, you can see those in leaf form, right? Because that's generally what they've done so far. Is that correct?
Yeah, that is correct. Until the leaf decides it's done, and then it will be dormant, and you will see nothing until the leaf decides to come back again. So, and a very common question is, well, how often do they flower? There's no rhyme or reason for that. How long do they stay dormant before putting up a leaf? No rhyme or reason. They do it when they're ready. There's no real calendar. You really can't mark it. Yeah, they do it when they're ready. So we started to talk a little bit about our conservation program.
Yeah.
So yeah, so as I said, so now there's this great new program that's being started by the scientists at Chicago Botanic Garden. And as I said, we've donated leaf samples of every single one of our plants so they could have the DNA. And so what we're going to do, we're participating in that program by they sent us pollen from 2 of their plants that they had bloom this year, that they have the DNA on and they know of, and also from the Laurentian Botanic Garden in Nebraska. So we have pollen from 3 different individuals that is in our freezer right now. And when these open up, and the first flowers to open, as I said, are the females, and they'll be receptive as soon as that thing opens and gets hot and super stinky. And we'll go in and we'll cut a hole in the side like Libby showed you earlier. And Libby, do you want to can you show that again? So we'll cut a hole in the side so that we can reach those female flowers. And we will take the pollen from those 3 plants that was sent to us, and we will pollinate the female flowers inside there. And then afterwards, we will harvest so then after 24 hours or so, the females Yep, and if we're successful, this is what we did in 2017, and we got lots and lots of seeds, and that's why we have so many plants at in our collection right now, because most of those grew successfully. So then what we're going to do is we're going to pollinate this guy, this gal right here when she blooms. And then when the males open up, we're going to collect the pollen. We're going to collect the pollen from them. And then we're going to ship those to Chicago to be put in deep freeze as well, so that they can send those out to appropriate institutions to make sure that we get a good cross of the a good cross-pollination, that we're increasing the diversity of this plant. And also we're talking with the folks from the Huntington Botanic Garden right now, who have one that's going to come into bloom very, very close to this one. And
right. We're kind of in a race, right? Yeah.
Yeah. So if they have pollen first, they're going to send us some pollen. And if we have pollen first, we're going to send them some pollen. And if nothing else, and you know, we also need to overnight it to San Diego. So I'm sorry, to Los Angeles. So if, did I say San Diego Botanic Garden? I'm sorry, I meant Huntington Botanic Garden, excuse me. That was a
you said Huntington, yeah, you're good.
Okay, Huntington Botanic Garden. So we have to overnight it, so that whole overnight mail thing. So, but we do have this one coming on after, so another 10 or 12 days. So if it doesn't look like we're going to make it with this first one, they're going to send us some pollen to pollinate the second one, because theirs also, they know the parents of theirs as well, and they're not related. So we'll just be increasing the diversity by pollinating that one as well. So yeah, we're going to be sharing. We've gotten pollen to pollinate. We're hopefully going to get some more pollen from someone else to pollinate, and we're going to share ours out so that it can be shared with other institutions as well.
And then, do we freeze our pollen in order to send it? Someone's asking in the chat.
Yeah. We're gonna send it to Chicago Botanic Garden because they have the deep freeze. They have the -80 cooler freezer that they can put it in, and then it's a good central location. So those folks that are working in the program, they can contact them that has the data on all the different plants and say, you know, ours is blooming, we'd like some. And then they can dole it out as, you know, if the institution has this, you know, the same parents as ours, if the same donor gave some seeds to someone else, then they won't bother, or, you know, so they'll be in control over it for now until
Wonderful.
The program gets underway.
So it's about 4:30. So if you have time for just maybe one more question, or one or two more,
sure.
That would be great.
I sure do.
Cool. Well, this one is a popular question. Scale of 1 to 10. How stinky is it when it's just like really pumping out that smell? Would you say?
It's pretty
what
vile.
Does it smell like?
It's pretty vile. It's pretty gross. I've smelled my share of dead animals in life, and you know, living in the city, lots of dead rats, and this is grosser than any of it. So it's like the worst dead animal you smelled, but actually even more acrid. Like it just, and I remember in 2017 when we pollinated the one that Libby showed you, I had to step away a few times because it was really gross. Yeah. So I'd say on a scale of 1 to 10, and there's other flowers out there too that do the same thing. They smell like rotting flesh to attract flies and beetles and things. There's some orchids that smell like that. There's a Stapelia, it's a succulent that smells like that. And this is far and away the grossest. Yeah.
Awesome. And then also, do you know how many other botanical gardens have corpse flowers in their collection? Or do you know?
Yeah, so there are about 70 to 80 gardens that actually have this in their collections. But there's also a lot in private hands as well. I know I've seen it in lots of university and school greenhouses. So it's not really uncommon in cultivation. It's not really common, but it's not rare. So about 70 to 80 public gardens have this. Those that keep accession collections like we do, accession database collections like we do. But you can buy it online. If you do an internet search, it is for sale, but from some nurseries. The hardest thing, though, is most people don't have the environment to grow it. As I said, we grow it year round between 70 and 85 degrees with 60 to 80% humidity. And that's a lot of people, and a lot of people don't have that environment in their home or a home greenhouse. And they also don't have 20 some foot tall ceilings to accommodate it when it's in leaf. So,
that is also important. Having those really tall ceilings probably comes in handy.
Gotta have tall ceilings.
Well, Jim, I really want to thank you. This has been an amazing conversation today and a wonderful amount of information for our visitors. So thank you very much for your time. Thanks everybody for joining us.